Very good afternoon, students. Welcome to IIT NEET or Focus C program by Krishnaveri Talent Schools and the Mastermind Schools. So once again, I welcome all the class 9 students for today's session. As you all can see on the screen and you are well aware, my subject is physics. We are in class 9th. Today we are going to start a new chapter, chapter number 5, work, power, energy. And today we are in the session number 1. So before going for the further explanation, so first let's know what is the importance of this chapter. See, work is a common word used in our day-to-day life because we cannot survive without work, whatever the type of work it may be. Okay, then if you are doing work very fast along with the time, some people can do the work fast, same work some may do. That depends on their power. And also capacity, your ability is known as energy. Means all the three terms are interlinked with each other. One is connected to other. They are not independent terms. Work, power, and energy are interrelated, interlinked, connected to each other. So here what we have discussed is, we have to discuss about what is work, what are the various types of works you can see, will come across in our day-to-day application. Then what is power? How can you measure the power in terms of work? Then what is your capacity? What is your ability? What is your tendency to do any work, which is called energy. There are various forms of energies you can see, which is neither be created nor be destroyed. So in this chapter, coming maybe 3 sessions, today and next week, we'll try to cover entire 3 topics in details so that you can appear for the 5th test number 5 on 25th November, right? So please focus on it. Along with this, I'll show the one video also which covers everything, right? So we'll start with the first term, that is first word, that is work. So see, you can see from as for your material, you can see here. First we'll do what is work. What is work done against the gravitational force? So what are the types of energies? Like is potential energy, kinetic energy, then work energy theorem, conservation of energy, and finally power. Work, energy, and power we are going to discuss, right? So first we'll see what is the work and what are the different types of works. Different types of works. Okay. Then we'll enter into the energy part. Energy part, right? Then what are the types of energies we can see in our day-to-day work? So every day we'll see so many types of energies, right? That we'll see. Clear? Now, so first we'll start with the work, which is the most important word in our regular life. Because what is work? When you said work is done, when a body displaces, when you apply some force, see, given see here clearly. Everybody moves, does some sort of work every day. Suppose you are there, you will do some work every day. You will move from house to school, school to house, you play games, you do work, homework, you listen to the classes. See, reading, thinking, or studying are examples of mental work. We do not recognize mental work in physics. No matter, it needs energy. So the mental works are not considered as a work in physics because there is no displacement. Right? So lifting the load, carrying the bucket of water, cooking, drawing water from well are all examples of physical work. In physics, only physical or technical work is recognized as a work done. Very important, you can see here. So even though you feel that you are doing very good work, even though I am feeling that I am teaching you and getting strained, I am not doing any work because I am doing the mental work here. Suppose in classroom, if a teacher, she moves here and there and will do the explain on board. That is exactly the work of the physics. So physics recognizes only physical and technical work only. They won't recognize mental work. So reading is not a work, right? Thinking is not a work. Studying is not a work. Don't feel that you are doing so much work. That is not a work. The work is the one. Suppose you are carrying a bucket of water from one place to another place, or you are lifting some load to move the body, or you are drawing a water from the well, or you are cycling to go to school. All these are the physical works. Some technical work you can do. Some industries, your parents will do that, some technical work at school. That is also a work only as per physics. Right? Hope you understand. And what is work according to physics? We can come. Because when you are knowing that there is a different meaning for work in physics, we should know what is that. So that is given here. Work is said to be done when a force displaces a body. That is, work done is equal to force into displacement. What? Either maybe you are applying force on a body, whether it's a pulling force or pushing force. Because force is nothing but either pushing or pulling. When you apply a pulling or pushing force on a body, if the body changes its position or the body displaces, then only you can say that work is done. Otherwise, there is no work. Suppose you are applying some force on your table to move it. So you are moving the table in classroom. If the table moves, you have done some work. But your force is not enough to move the table, no work is done. Can you move the wall? You apply force on a wall to move the wall to make your room bigger. You are applying force, but wall is not moving because your force is not sufficient to move the wall. So there is no work is done as per physics. As the body displaces in the direction of force, then only body is said to be done, work is said to be done. That is mathematically given by W is equal to force into displacement. So force is measured in Newton, right? And displacement is in meter, Newton meter. Or it is also measured in dyne or erg. Later we'll come across one by one. So example you can see. When an engine moves a train along a railway line, it is said to be work done. Without engine, we cannot move the railway line. Okay, it moves, engine will move. A horse pulling a cart also doing work. How the cart is moving? Because of horse. A man climbing a stairs of house is also doing work in moving himself against the force of gravity. You are climbing the steps or coming down. All these are nothing but work done. So mathematically you can see work done is a moving a body equal to the product of force exerted and displaced distance moved, what I told. That is the definition. W is equal to F into S. Right? That is called work done. When a body displaces along the direction of force, then only work is said to be done as per the physics. Body must displace along the direction of force. You can see here. So initial position of the body is here, but body moves up to final position with the displacement of S on the application of force. So body is moving from here to here. So what you can say? The work is done because of the force. That is, force into displacement will give the work done. Right? So that is mathematically given by W is equal to F into S. So unit you can see here, unit of work. So work is, unit is erg in CGS system. Erg is in CGS system, and in MKS system it is joule, sorry, not dyne. Joule. Joule is in MKS system or SI system. So work is measured in either erg or joule. Right? It is mathematically given by W into W is equal to F into S. So work is said to be done if the body displaces along the direction of force. Okay, along the direction of force, which is mathematically given by W is equal to F into S. That is, the work is measured in either Newton meter or dyne centimeter or joule or erg. Right? That is completely about the work. So there are different types of works are there. Either it may be positive work or negative work or zero work. Types of works. Number one is positive work. Number two is negative work. Number three is zero work. Very simple this is. Very important also. Positive work means if the work is done along the direction of force applied. Suppose you are pulling a table or pushing a table. When you push in one direction, the table will be same direction. Then you can say positive work is done. Badang page, please switch off the video. Right. So if the body moves along the direction of force, said to be positive work when the body is moved same direction of force applied. Any case you can take, we are opening the door. We are pulling the door or pushing the door. It is a positive work only. Suppose if the body moves opposite direction, other direction. For example, when you go to the park, there is a grass cutting machine with there. You are cutting the grass. So we'll apply the force in downward direction like this. So apply force like this. There is a roller. Roller will move in this direction. You are applying force in downward direction. Roller move in this direction. Road roller or a lawn roller, we can call it as lawn roller, right? To cut the grass we'll use. So you are applying force by holding the handle. We'll apply force in downward direction, but roller is moving in this direction. So this is not a positive work because actually force is this. Body goes this direction, positive, but it's going in some other direction with angle. That is called negative work. See, there are so many examples. If the work done by force on a body is said to be negative work, when the body displaces in the direction opposite to the direction of force. If same direction it moves, positive work. If opposite direction, negative work. Example C. When an object lifted upwards, certain height, when you are lifting the body, against the gravitational force. Gravitational force is acting in downward direction, but we are lifting in the upward direction. That is also a negative work. Right. Second one you can see. Work done by a frictional force. As friction is always negative only. When body moves in one direction, frictional force always comes into opposite direction. That is also a negative work. So work done by a person with a suitcase on his head moving upward direction. Holding the suitcase when you go to railway station, bus stand, coolies will hold the turn and they'll move in the upward direction or downward direction. That is also a negative work because going against the gravitational force. Zero work. Zero work means there is no work is done. Already I told there is no mental work, nothing. So that is force into displacement is zero. When happens W is equal to Fs is the formula. When work becomes zero, either force zero or displacement zero. Right. In such case, there is a formula is there. W is equal to F into S cos theta. Whenever a force makes an angle with a displacement, means force in one direction and displacement in other direction, they makes angle with each other. Suppose the angle is 90 degrees. Cos 90. In trigonometry you come across, you may be knowing. Cos 90 is 0. So total Fs becomes 0. So work done is 0. Suppose when you go to railway station, coolie will hold the object on his head and it will move. Means his force is acting 90 degrees to the displacement. Means the work done by the coolie is 0 as per physics. So don't argue with him that you have not done any work. I am not going to give any money. As per physics, that is not work. But physically, mentally is doing work. Some work is doing. So that is called zero work, where the work done is 0 when either force is 0 or displacement is 0. So There are three types of works. Positive works, when force and displacement are in same direction. Negative work, when force and displacement are in opposite direction, like lifting a body. And zero work, when the either force is zero or displacement is zero. This is clearly about the entire work. So before going for the further topic, I'll show you one video which is related total chapter, but let us see the video for some time being, then we'll move to the next topic. Okay.
I have to do lots of work. I'm so tired. I don't have any more energy now.
Mom, why do you need energy?
Son, we do lots of work daily. Reading, writing, thinking, cycling, etc. So we need energy to do all these activities.
Mom, this washing machine also does work. Does this also need energy?
Yes, but there's a difference. Come, I will tell you about the work and the energy.
Objectives. At the end of this lesson, you'll be able to define work and energy, write different forms of energy, write the expression for kinetic and potential energy, understand the laws of conservation of energy,
Total chapter.
define power, write the units of work, energy and power.
What we are going to learn is the coming days also same. So one video will give clear picture, clear idea about total chapter.
Work. Friends, we do lots of work like playing, studying, cycling, running, etc. All these works require a lot of energy. But the scientific definition of hard work may involve very little work. Let's see how. Look at this huge truck. We work hard to push it, but the truck does not move despite all the effort. We get tired. However, we have not done any work on the truck as there is no displacement of the truck. We can say that we did hard work, but in science, the work is not done on the truck.
विवेक आप गए नहीं सर वो
We use and define the term work differently in science. For example, if we climb up a cliff, then according to science, we have done lots of work. Scientific conception of work. For work to be done, these two conditions should be satisfied. First is, a force should act on an object. Second is, the object must be displaced. Let's take a look at a few situations. If we pull a table and the table moves through a distance, here we have exerted a force on the table and it is displaced. So both the conditions are satisfied here. Therefore, work is done. Similarly, while playing cricket, if we hit a ball with a bat, then work is done because force is exerted on the ball and that ball is displaced. Work done by a constant force. To understand the concept of work in science, let us consider a case. Case is, the force is acting in the direction of displacement. Let a constant force F act on an object. Let the object be displaced through a distance S in the direction of the force. Let W be the work done. We define work to be equal to the product of the force and displacement. Work done is equal to force into displacement, or W is equal to F into S. Thus, work done by force acting on an object is equal to the magnitude of the force multiplied by the distance moved in the direction of the force. Work has only magnitude and no direction. If F is equal to 1N and S is equal to 1M, then the work done by the force will be 1 Nm. The unit of work is Newton meter or joule. Thus, 1 Newton meter or 1 joule, is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of action of the force. Example. Let's now find the work done when force applied and displacement is given. A student lifts his school bag from the ground and puts it on his shoulders, 1.5 meter above the ground. A force of 5 Newton is acting on an object. Calculate the work done by him on the school bag. We can see that here force applied is 5 Newton and displacement S is 1.5 meter. We know that work done is equal to force into displacement. Therefore, we get work done is equal to 7.5 Newton meter or 7.5 joule.
A simple calculation.
Energy.
To understand the
We now know that to do any kind of work, we need energy. We must have energy to accomplish work. But the question is, where does this energy come from? The sun is the biggest natural
Second
source
part,
of
that is
energy
about
to
energy.
us. Many of our energy sources are derived from the sun. Energy sources are classified into 2 groups: non-renewable and renewable. Most of our energy comes from non-renewable energy sources: coal, petroleum, natural gas, propane, and uranium are non-renewable energy sources. They are used to make electricity, to heat our homes, to move our cars, and to manufacture all kinds of products. These energy sources are called non-renewable because their supplies are
Can be
limited.
not usable.
Renewable energy sources include biomass, geothermal energy,
Solar.
hydropower, solar energy, and wind energy. They are called renewable energy sources because they are replenished in a short time. We use renewable energy sources mainly to make electricity. An object having a capability to do work is said to possess energy. The object which does the work loses energy, and the object on which the work is done gains energy. The energy possessed by an object is thus measured in terms of its capacity of doing work. The unit of energy is, therefore, the same as that of work, that is, joule. 1 joule is the energy required to do 1 joule of work. Sometimes a larger unit of energy called kilojoule is used. 1 kilojoule equals 1000 joules.
Right. Beautifully explained about the energy also.
Forms of energy.
How many
There
types
are
of
many
energies
different
are there?
forms of energies. These various forms include potential energy, kinetic energy, heat energy, chemical energy, electrical energy, and light energy.
See,
Let us first study about kinetic energy. We know that a moving object can do work, and an object moving faster can do more work than an identical object moving relatively slow. Kinetic energy is the energy possessed by an object due to its motion. The kinetic energy of an object increases with its speed. Turning wheel, moving car, boy running are the examples of kinetic energy.
there.
So we say that the kinetic energy of a body moving with a certain velocity is equal to the work done on it to make it acquire that velocity.
Right. See how nicely explained about the energy also.
Equation of kinetic energy.
mv square.
Let us now express the kinetic energy of an object in the form of an equation. Consider an object of mass m
Mathematical formula of
moving
energy.
with a uniform velocity u. Let it now be displaced through a distance s when a constant force F acts on it in the direction of its displacement. We know that the work done W is Fs. The work done on the object will cause a change in its velocity. Let its velocity change from u to v. Let A be the acceleration produced. The relation connecting the initial velocity u and final velocity v of an object moving with a uniform acceleration a, and the displacement s is v square minus u square equal to 2as. This gives s is equal to v square minus u square whole upon 2a. We know that F is equal to ma. So by using values of F and S in the equation of work, we get W is equal to ma into v square minus u square whole upon 2a. Or we can write it as W is equal to 1 upon 2 into m into v square minus u square. If the object is starting from its stationary position, this is u is equal to 0,
Okay.
then the work done,
So we'll continue the
W
video
is
in the
equal to
next
1
class
upon
because we are going to discuss about the same in the next class about energies. So, but we are very much clear about the work done till the date, right? So, what we have learned is what is the work done, what are the different types of works in the positive work, negative work, and zero work with various examples we have seen, right? So, in next class, we'll know about something about the gravitational work done against the gravitational force, and then we'll enter into the energy part. Okay, different types of energies, work energy theorem, and finally by what is the power. So how you define the power. Okay, so that's all for today. You can see the homework here, home task here. Define work, mention type of work done. Okay, you mention what is work done as per the physics, and different types of works like positive work, negative work, and zero work. Write your notebook and take signature from your teachers and parents. Right? So that's all for today. Thank you, all of you. Have a wonderful day. Thank you. Right? So get ready with the next class where we are going to learn about energy and followed by the power, which is our test to 5 syllabus. So before that, you go through the daily, whatever you covered, you go through it and try to practice the worksheets also. Due to lack of time, you are unable to do the worksheet. You have to complete from your end. Complete them and get ready for the test to 5, all of you. Right? So thank you, all of you. Have a wonderful day.